Sample problem 10.2. If a skin diver takes a breath at the surface, filling his lungs with 5.82 liters of air, what volume will the air in his lungs occupy when he dives to a depth where the pressure is 1.92 atmospheres? Assume that the constant temperature and that the pressure at the surface is exactly 1 atm. So here's what's happening. You got the surface of the water. The skin diver is headed down underwater to where the pressure here is 1.92 atmosphere. And then they tell you when he's at the surface, it's 1 atmosphere. Exactly 1. Now, when someone says exactly, from a sig fig perspective, what that means is 0.000 ... In other words, there's an infinite number of sig figs there. They also tell us the temperature is constant. Okay. We're also told that if the skin diver is at the surface, he takes a breath of air, and his lungs have a volume of 5.82 liters, and we want to find what the volume of the lungs are down here. Okay? This is what's called Boyle's law. Boyle's law says P1V1 equals P2V2 as long as the temperature is constant. So you want to identify these types of problems. Boyle's law, pressure times volume up here is equal to pressure times volume down here as long as the temperature is constant. If the temperature is not constant, then we have to do something else. Okay? So here's what we do. We use this equation, Boyle's law. And I'm going to call 2 down here and 1 up here. You don't have to, but I'm going to do it that way. So that means 1 atmosphere times 5.82 liters, P1 and V1, those multiplied together is equal to 1.92 atmospheres times V2. Okay? So I'm going to rearrange this. What we're trying to do is we're trying to find the volume at the bottom, V2. So P1 times V1 divided by P2. And that'll give you V2, the volume when you're down underwater. Okay? So then we just go ahead and plug those numbers in. P1 is 1 atmosphere. Exactly 1 atmosphere. Times 5.82 liters. Divided by P2, which is 1.92 atmospheres. And that's equal to V2. Okay, so let's try that. 1 times 5.82 divided by 1.92. 3.03. And look at the atmospheres cancel, and you just got liters. Those are the units of volume. Okay? So there's a Boyle's law problem. Think about it physically. Essentially what happened is the lung, a little sphere for the lungs. Remember, what we said is the lungs are essentially like a balloon. You've got air in there, and there's an air pressure in there. The pressure outside is equal to the pressure inside, so the lungs are constant size. But as you go down, the pressure due to the water increases the external pressure, right? This is called external pressure. So what happens then is that external pressure makes the lungs smaller, right? Until the pressure inside here is now equal to the pressure out here. And once those two pressures are equal, then the volume stops changing. So that occurs when the volume of the lungs goes down to a little over 3 liters. Boyle's law.